So you're looking for like patterns. You're like, well, what's going on here with the x's? Anything happening to the x's? Like how does -1 go to -4? Which doesn't,
I mean,
doesn't
I would assume like, just subtract 3.
that would normally be the case. These all appear to be stretches though, which doesn't make sense. What am I? Is this really -1 to -4?
So then that would be multiplied by 4.
Oh, you know what it is? There's more. There's more than I didn't even notice this. There is a reflection also. That's why this isn't working out. So they're being very difficult here. It is actually that -1 goes to the 2, and the 2 goes to the -4 because it's actually a reflection over the y-axis as well. This is very hard to see. Wouldn't expect anyone to see this, I guess, first glance. So this point here is actually going to that point.
I gotcha. Okay.
That's why this wasn't syncing up. So the 2 to the 4 is -2, the 1 to the 2 is -2, but because it's over the y-axis, it's a negative. This b right here is -2, but what that normally does, and so everything's flipped when it's inside. So what it normally does is you normally think of when you multiply by 2, it's -2. Because it's inside, it ends up being 1/2. It's the reciprocal. And I'm hoping that's actually the way that they do these things. Now, the y values are more specific, but again, you kind of got this thing. It's like, okay, well, this -2
Is it
goes
so?
to negative.
It would be the I'm so sorry, man. It would be the multiplication because b of x and that is ultimately affecting f of x. And in order to get that like -2, you would be multiplying by the reciprocal of -1/2, right? So like,
Yes, but it's only affecting the x values, not you said f of x. It's only affecting the x values is the inside part.
okay.
These are the hardest to understand and to explain for that matter is it's
Sorry to hit you with it, man.
that's okay. No, this is it's hard to explain because it doesn't follow our intuition. We think, oh, I multiply by 2, but it's always flipped on the inside.
Okay.
So if it were to have gotten narrower, then it would be a ×2, but the wider is a number between 0 and 1.
Got it. That makes sense.
Okay. The part on the outside is whether it's been pulled up or down, which it has not been. Notice all the values go to the same y values. So the a in this case is 1. I guess that's just what they're looking for here is a and b.
Like -2 would be flipped over to -4, -2. All right. So it would, so from x to get from -1 to -1 to 2 -1, where we have to multiply b of x by -1/2.
Your x, what happens is your x values become -2 times your x values, but you undo it by dividing by 2, which is this, do that on both sides and it becomes -1/2.
Kind of
The
going
reciprocal.
backwards. I gotcha.
So here's the analogy, and this isn't perfect, but it's an analogy. X plus 3 squared is 3 left, whereas x minus 2 squared is 2 right. It's kind of counterintuitive to what we think it should be.
Totally get that. You
And
know what
that's
I
the
mean? 'Cause
same
that
reason why
affects
it's
the x. That
Yeah.
totally makes sense. So having the half in front would,
Inside the function.
yeah, yeah, sorry, inside the function and in front of X, you know what I mean? So multiplied by X. So like, let's say, you know what I mean, A of F times, so X would be -1. And so it would be like 2 to -1, or wait. Oh, okay, I get it. I get it. It would be -2. So X going to 2 would be -2. And then that would be, what is it? -1/2 in front of B. That makes sense. Okay. And then,
Is that okay? Clear?
yeah, I mean, I get that this is like one of the harder aspects of, you know what I mean, algebra.
Transformations. They're just, I mean, it's analogous to, I guess, like there's things that sort of are, I don't know, like inside, outside, things that work in one place, but not the other.
So why, okay, and that would make sense that A is 1 because there is no transformation happening from on
Right.
to the Y's. Okay, that makes sense, man. So A would be 1 and B would be -1/2. Okay. Because multiplication is really division of the 1/2. That's just the way I'm gonna remember that.
Yeah, this thing I did here on the right does work with the left and the right because you end up undoing it. But it's not a great, it's easier to explain this from the beginning rather than jumping in from middle of a problem.
And
Plus
that
this
that
one,
would,
go ahead.
oh, sorry, go ahead. I'm cutting you off. I apologize.
I was just gonna say, plus the fact that this is a reflection. I mean, they've really not they're sort of a way to step you through these transformations. They didn't do that in this problem. They just give you all of them at once, and it's very challenging. All of it's gonna sort of say. Number
Yeah, this
15 will
whole
make,
course is kind of, it seems like built for just stumbling, which I'm not really appreciative of, you know what I mean? But it is what
yeah.
it is.
So if we can move to 15, I think you'll have a little more clarity here on what's going on. It's important to know what the parent function looks like. The parent function here is x squared. It's like what it should look like.
Okay,
And
sorry, I'm looking
go
at
ahead.
15. I'm gonna look at you right now. All right, go ahead.
Yeah, so what does the parent function look like? And if you go to like Desmos graphing, you can graph this and see that it looks something like this, okay?
Yeah, I'm familiar with kind of like the parent functions and what they look like from like the 0, 0 vertex.
Yeah.
Yeah.
So this one on the left, it has some things that's different. There's a couple of things you probably noticed. The first is that the vertex has moved.
Yep.
So in words, it's moved left 3 and up 2.
All right,
Okay.
so really quick, just so, because I've kind of already gone through these lessons a little bit. From what I would do right here is I would look at that and yeah, left 3. So technically like X plus 3 in the parentheses up to, that would be +2 outside of the parentheses. And then based upon the fact that it's inversed over the what is it, X
X
axis.
axis.
Yep. That would be a what is it? Multiplication, a negative multiplication of, what is it? So it's I'm forgetting that fucking equation. It's like,
Vertex form, but it's negative here. It'd be you've got it right. And now the only thing that I heard that wasn't quite right, left 3, it is inside here. It's not +3 though, it is -3. I'm sorry, it's +3. I don't remember if you said -3, but just be clear, it's always opposite to get there.
Really quick, what would happen if we took that negative and then put it in front of the X? That'd be flipped over the Y. And what would that look like on this particular problem?
So here's what you just said. You're asking me, what does this do now? Is this negative still in front or not?
No, negative's
Okay.
not in front. Just what's the, yeah, what you
Okay.
got
So
written
you
down.
you would factor out a negative from both things inside parentheses. And then you would square both of them. So it's really -1. It would be -1 squared x minus 3 squared. And so -1 squared goes away. So it would just be x minus 3 squared plus 2. So notice the key difference is that it would be, instead of being left 3, it would now be right 3. And why is that? Because the difference between when you put a negative inside, it's a reflection over the y-axis. So you're moving that point from being left 3 to right 3, you're reflecting over this.
Yeah, that
That's a
makes,
very, very advanced thing to be thinking about. It's way out of scope for this course. You don't need to know that. You need to know that left 3 is +3 and right 3 is -3.
they're including the negatives, the vertical and horizontal stretch and all that stuff.
Okay. Okay.
So it's definitely in the curriculum, which is kind of why I was wondering what the difference between the two would look like. So negative x plus 3 inside the parentheses is just it flipped upside down.
No. It's from this to this. So it flips over the y-axis. It goes from left 3 to right 3. You're reflecting.
Okay. Okay. And then outside of it is flipped upside down. Yep. Right. I'm making sense. I'm not totally tripping out here.
No, you're not. You've got a firm grasp of this. It's good. Good to hear.
Okay. So negative, write this down. X plus 3 would be flipped upside down. And then negative x minus 3 would be completely on the other side. And that's where you're doing the multiplication there. So, yeah, so if you just had a minus in front of that x, wouldn't you be, and I see you got the squared outside of it. What if the squared was inside that second set of parentheses right there?
You mean like squared with the
So
x?
down 2, and then that exponent is moved inside,
Well, that's what we do in the next line.
but you're also squaring -1.
Yeah, so that is the idea, is that a times b squared is a squared b squared. And so if you have a -1 on the outside, you square it and you square this thing. If you're trying to put it here, it's like going back a line and keep the negative with the x. Like you're going one way or the other, backwards or forwards, depending on.
Okay.
And the quadratic's not the good one to show for transformations over the y-axis. The better ones are root functions and other things. But because there's a lot of symmetry with quadratics, it's not a good choice.
And by quadratics, when we say quadratics, what
Power of 2.
exactly? Oh,
Power
okay.
of 2, U-shaped.
Gotcha. That's good to know. I'm not familiar with the terms.
Good to ask.
All right. Let me,
Yeah. So, I mean, if you're not, please check these along the way, because I don't want you to get, where it's not right and there's a question. I mean, I'm not, sometimes I make mistakes and I want to make sure you get these right as well.
okay. Let me plug this in and
Same thing with the previous one. I have some concern that B is not, there's some
no,
potential that they're doing.
that was
Okay.
correct.
All right.
That was correct. +2. I'm gonna have to sit on this and continue like learning it for sure. Okay, that one. All right, I need a different one. Okay, so is the vertex of the one I just showed you? All right, so basically that shifted down to -3, -1.
Okay,
Because I think I plugged it in wrong. I apologize, man.
it's okay. I mean, so the only change there is this, instead of up two, it will be down one minus one.
X plus 3 squared -1. Okay, yeah, that makes sense. I get that. X plus 3 squared -1. All right, yeah, that's correct.
All right, number 18. Is that okay?
Yep. Okay, really quick, just to see. So it would be multiplying outside. So that would technically be like multiplying A. And if it's multiplying A, then it's going to be, what is it? A vertical stretch?
Yes. Yeah, this one has three transformations, and the order does matter. The vertex is also something that would be helpful to know. The standard form here, let me draw that, write that above it. So the standard form is a x minus h squared plus k. So this value of h is always opposite of what's inside parentheses. So the vertex is h comma k. You've got to identify the value of h and k. H is always opposite of what's inside parentheses. So vertex is -3 comma, k is -5.
Let me write that down really quick. X minus h squared plus k. And then the vertex is hk. And h is always going to be the opposite of what's in the parentheses right there.
That's the best way to remember it, I've found. Up to you to
Okay, so in
you want to
this
remember it
case,
that way.
it would be -3, -5.
Yes. You'll notice only one of these graphs actually has that, but here are the transformations: left 3, okay, and then down 5. And the order matters. The order really does matter here, especially in more complicated problems. This 2 is exactly what you said, vertical stretch. You got to say both vertical and stretch, because there's also a compress, or maybe these in other words, a word of 2.
Okay. -5. Yeah. So finding the vertex in this particular circumstance is just kind of like a shortcut to understanding what that full like equation actually means. That makes sense.
I mean, this is not a good problem, because they should give you 2 of the 4 graphs should be with that vertex, but only one of them has the right vertex.
Gotcha. In order to show that stretch essentially.
Yeah, because you don't even need to think about why this is a stretch. You just know that it's the only one that has the vertex.
That makes sense. Yeah. Anyway, this course is stupid. It is what it is. I really appreciate your help.
Yeah, sure.
That definitely I'm going to be using that formula moving forward.
Any questions on that before we move to 19?
So as far as the vertical stretch, so when that 2 is on the outside, that technically means that we are dividing the y values by 2.
When it's outside, it's exactly what you think it is intuitively. Stretch means multiplication on the outside.
Okay.
On the
Gotcha.
outside, just like -5 means down 5 because it's on the outside.
Okay. Because y equals duh. Okay. Yeah. That makes sense. All right. So here we go. We got we got a vertical stretch.
You talking
And
about for 19 or 18? Going on 19?
yeah, I got 9. I already got 18 plugged in or whatever.
Okay, all right.
So for 19, we have negative to the absolute value of x equals y. So the y values will be negative, obviously. So it's flipped upside down.
It's true.
And then the y values are also stretched, correct?
Stretch multiplied by 2. So
Okay.
notice there's no change to the x values.
Yep, totally.
So
That
so
totally
th-
makes
this is another way to do it. I was about to do it in the previous problem, but we'll do it for this one. Is you can use a table from the parent function. So on the left is the parent function. That's the v that you're used to seeing for absolute value of x. And then you have to figure out, well, what is being affected? It's only the y values. You're negating them, and then you're multiplying by 2, or you're multiplying by 2 and then negating them, or you can just multiply by -2. All of those are correct.
that makes
Sometimes seeing the table helps to clarify some things. It just depends on, what kind of a learner you are, whether you need to see it or you like to see the explanation. What you'll see though is that it is stretched, like you just mentioned. It's narrower than the regular one, and it does go down. And so you're looking for, you want to use this tool here. You probably figured that out, and you've got to graph both the vertex and then a point on it, and it should snap the rest of the graph there together.
so in this case, the vertex would be 0, obviously.
0, 0, yes.
And then, that would be 0. Yeah, that makes sense. And then 1, so we'll do 1 or -2. Yeah, that's fine. -2. That makes sense. So then it would be 2 times 2 for -4. That makes sense. So it would be x -2, and then y is -4. And then x for 1, -1, it would be 1 times 2 negative, so -2, and so on and so forth. 1, -2, and 2, -4. That makes sense. That totally makes sense. Oh my God, thank you, dude. Holy crap.
Good.
Yes. Yes. Do 2, -4. Just like that. And that should, yep, slope a negative. Well, it's both. It's
So
both.
that's the important thing you just said there is this number in front does represent the slope going to the right. This line to the right has a slope of -2.
Okay, and that's yeah, that makes sense. So would that, and that's always what I want to look at, is that right side of the graph for the slope.
That's the shortcut. The shortcut is to not make a table and to manipulate it. Like the shortcut is to graph the vertex first and then use the slope to graph new points, then to mirror it on the other side.
Gotcha. That totally makes sense. Okay. And then you could use that vertex situation with the a, times x minus h squared plus k in order to kind of figure it out from there.
Yes, lots of options. Just depends on what you.
Million ways to skin that cat. Totally get
Yeah.
it. Okay, so for number 20, if you wouldn't mind, just because it helps me out, can I let me try and see if I can do this really quick. -2 x plus 1, and the absolute value of that plus 1. So with the x and the y table, we'll go -1, 1, 0. Go to the new one, so x and y. Man, it has been like 13 years since I've actually tried to do this. Holy crap. So we got -1 + 1, 0 multiplied by, you know what I mean? -2 is still 0, and then +1. So it would be, what is it? The same? -1 and then 1 for the y value. And let's do 3. Actually, we'll do 0. So 0 + 1. Would be 1 multiplied by -2, and then -1. And then for 3, we have, what is it? 4 times 2, so 8. -8 + 1, -7. So that might look like vertex. And then 3, -7. 1, 2. Oh, well, obviously right there. I mean, you can't see my screen, but
So why don't I graph the vertex here and then go from there? So I think I heard you say -1, 1 is the vertex.
no, the vertex would be 0, -1.
Is yours different than this?
No, I'm just being an idiot.
So one of the things that does help is to write the transformation. So the first one is from inside here, which is left 1. And then the order doesn't matter. A lot of students say like the vertex +1 is down 1. That's actually the last thing that you do. Then there's this negative and it's 2 out in front, and you correctly identified as in the previous problem. It's, and the order doesn't matter, but it's a reflection over the x-axis, and then it's a vertical stretch of 2. And the transformations help you to make the table or to just go to the graph and make sure you're right when you like, does it sync up with this? The shortcut here is to graph the vertex point. The vertex is at -1, 1. Okay, and then use the -2 as the slopes. That's down 2, right 1, down 2, right 1. And then there's symmetry. There's symmetry across this line here. So you just bounce across it. There's other ways to do it, but that's pretty reasonable here. And that's your graph. If you don't like that, we can make the table. There's lots of ways to do this. You just have to decide what you like.
Do you mind if we actually do let me see really quick here.
Again, you can make it coast, you can share your screen, you can just tell me the problem, whatever would be best to help you.
Okay. So that's right. I'm gonna do another one. And I'm gonna share my screen if that's okay.
Yeah, I have to click a few buttons here to make you co-host. So let me do that. All right, you should be able to share your screen whenever you're ready.
Okie doke. Let's get me going. Go. All right, so for this one, -2x. So the vertical stretch is still there, and then x + 1.
Yeah, why don't you try graphing this one, and I'll jump in if I see anything that's off.
Okay. Vertex is -1, -2. Let me get this table going. So the x value would come from me, obviously, like plugging a number in 2x and then adding 1 to it in this circumstance and taking the absolute value of that.
The vertex, it comes, the vertex comes just like with the quadratic, where it's the opposite of what's inside the parentheses of the bracket. So instead of being +1, it's -1, or it's to the left 1.
Gotcha. And I would probably figure out the vertex by plugging numbers into X, right? If I weren't using that formula, right? And just kind of following a pattern. That
You have
makes
to be
sense.
careful that you see it, that you get to where it's, I don't know, it's like, you want to see you could get points that always go along the line where it's never coming back to the V part.
Okay,
And so you gotta be careful what numbers you plug in. You really want the one that makes it 0. And so notice like -1 makes X plus 1 0.
gotcha. And that would technically be the vertex, is
Yes,
plugging
that's
in
the,
0 for X.
well, whatever makes X plus 1 0, whatever's inside the absolute value 0,
Okay, X plus 1 equals 0. Gotcha.
which is -1, and that's the center of your table. That is where your vertex is. And yes, you are then putting in points from there.
For sure. That totally makes sense. So that would be -2, and then we'll do -3. -3 plus 1, -2, absolute value is 2, times 2 is 4, so -4 minus 2, -6. So it would look a little bit like 1, -2 here, and then -3 to -1, 2, 3, 4, 5, and 6. Am I totally off here?
All right, so -1, -2, and then you've got the slope. So
Oh,
your slope is off on the one on both sides. You've gone down 4, and you really want to move that point up right there.
shouldn't.
Now, really, the point should have been on the other side, because that's you go to the right with slope. Even though this is correct, the point should be where you're from that top point, you're going down to right one.
So to get my Y value, I'm plugging in -3. So -3 to -2, because plus 1. And the
Okay. Oh,
absolute value of that would be,
I see. I see how you're doing it. Yes, that does work. So, but you're plugging, what are you plugging in for X? I'm sorry, didn't follow.
no worries, no worries. So I'm gonna plug in -3. So I have -3
Okay,
plus 1, and that's -2. The absolute value of that would be 2
okay, times the
times
negative.
2, which is a
Yeah.
negative, yep. And then -4 minus 2 is -6, and that's my Y value. So X would be
Right,
-3, and then Y value
right.
would be -6.
So that's fine. The point you have though is when X is -2, not -3.
Oh, because X plus 1, that makes sense, and that would be my X value.
So I think, so you had the right point. I just think you just didn't count. I'll just say, like, you just need to go over one more to the left and then down -6. So if you put -1 in for X, you'll get that point that you graphed there in red where your cursor is. -2 plus 1 is -1. The absolute value -1 is 1, times -2 is -2, -2 is -4.
And that would be for -2 or
Yes.
okay, so -2. Let's see, so if I'm plugging in 3 for X, be X plus 1 is 4 times -2, so -8. Or 8, and then -2, so it would be 4 and -10. So let's do a smaller one. So just plugging in 2. So 2 plus 1 would be 3. Absolute value times -2. is -6. And then -2, -8. So it'd be 3 and man, I'm so sorry. I'm like having a brain fart here.
I'm happy to show you how to work these out on my side. Would that help?
Yeah, let's do that.
Okay. All right, so if you see my screen here, the function, just rewrite it here, -2, absolute value of x plus 1, -2. You're saying all the right things. Let's just try -2 here. -2, absolute value, -2 plus 1, -2. So you evaluate what's inside absolute value first, like that. And you don't want to do more than one thing at a time, so just do one step here. Absolute value of -1 is 1. Once you take the absolute value, you can drop the absolute value. You're just multiplying now. -2 times 1 is -2, -2 is -4.
So my coordinate would be -1, -4.
No, -2. You put in -2 for x.
That makes sense.
And you had that. You have that already there in red. I saw, -2, 1, 2, 3, 4. It's already there. And you did the same thing for -1. Like you have this on your graph. We can work that out as well if we need.
I'm just writing this down really quick. All
Sure.
right. X equals, so we'll do our x coordinate at -2. And then that means our y coordinate will be -1, -2, -2. It's -4. So -2, -4. That makes sense. And then for the vertex, -1, -2 based on that formula. And you can kind of get it from there, or just by plugging in shit or whatever. Okay. That makes sense. 2, -4. All right, yeah, that's obviously correct. Cool. Sweet. And then for 21, all right, well, I already got that one right.
Yeah, that's everything that you sent me. So you're gonna either have to share your screen or pass along some other questions some other ways.
Yeah, let's share my
Drop them in the chat.
screen back a little bit and see if I can knock out a couple more just while I have you for a few more minutes. Really get it down pat.
All right. If you want to share your screen whenever you're ready, can take a look.
Doke. So we'll go back to 14.
Okay.
It's looking for the transformation of this particular graph.
Yep.
So we're gonna plot the points, and it doesn't look like that's been, reflected.
No reflection this time. That's good.
Yep. All right, so we got 2, -1.
Be careful. The order you gave is not. It's left, right, and then up, down. So it should be -1, 2 for that.
Thank you. Thank you, thank you. And then we have 0, -1. And then 2, -2. And that's going to, what is it, -2, 2. 0, -1 again. And then looks like 4, -2. So the change is happening to the x coordinates.
That's correct.
And it looks like it's just multiplying by 2. So this answer would be B equals 2 and A equals 1.
So B is always, because it's inside, it's the reciprocal of that. It would be 1/2 on the inside.
And if that were the case with the Y's, would that also be or
No,
that
it
would
would,
be
it'd be the,
as it's thought? Okay, that makes
yeah,
sense.
like if that on that new graph, instead of it being -2, 2, it was pulled up to -2, 4, that would be a 2 on the outside.
So it's B of X and it's going to be 1 over whatever it is multiplied by a factor of or whatnot. Okay. 1 and 1/2. I'm gonna do it one more time, just to
Yeah, no, that's good. That's,
really see if I can get it here.
hopefully the site responds. There it is.
Okay, and then this is reflected over the y-axis.
Yeah, yeah.
Okay,
They're not actually doing any vertical transformations in this problem. Uh, any of the ones we've seen, surprisingly.
so it's always going to be a negative b in this case because it's over the
Yes,
y. Okay,
yes, exactly.
gotcha. So -1. Is this no? This isn't the same one we started with.
It's a little different.
Okay, and then 0, -1, and then 2, 1. And then that's going from 3, 0. Obviously, it's just the x's, so 0 and then -6. So because this is being multiplied by -3, b would be -1/3.
That is what I saw there. Yes, out
Okay.
to -6, not a yes.
Okay. Sick. All right, I'm gonna do this one real quick again.
Okay, good.
So for transformation of x, because this is flipped over the x-axis, then it would be like a -a, correct?
Yes, there'd be a negative in front.
Okay. And not in parentheses or anything like that, so negative, and then it would be x, and because it's shifted over to the left 3, then it would be +3 squared, and then down 2, so -2. Can you see my
Agreed.
screen?
Yep, yep, yep. Looks what you said was correct with the +3 squared -2. Good.
Ah, dude, I think I'm totally getting this, man. Holy
That's good.
crap. That's
Yeah,
you.
your knowledge is, I mean, it's clear you're understanding this. I mean, you're asking good questions. I don't, most students really struggle with this, but you're doing great.
All right, so I'm gonna do this one really quick. I think I only have you for like 3 more minutes. This is easy. Downward would be 7x, and that would be -9. And that would be 7x plus, oops, +1.
What I can't tell, that doesn't look like it's in the exponent. So sometimes you have to put parentheses first in the exponent to kind of make it take that.
Oh, like this?
No, well, that would work. Do an exponent at some point, and then you want really, it's x plus one in the exponent. So now it's no longer in the exponent.
Okay, why is that? That it's in
Uh,
the
wait,
exponent?
in this case, the base function is an exponential where the transformations occur in the exponent, because that's what the variable is. Why the system just requires you to do it that way. So
Basically,
that
like it's whenever it's moved to the left or right, it's always adding or subtracting from X,
that's
regardless
right.
of whether or not that's in the exponent or in the parentheses or whatever.
Well,
Okay,
so if you put the exponent in parentheses to start, which is a little weird, but if you put it in there to start, you know to manipulate it inside like that. Now you know to do plus or minus inside parentheses there.
gotcha. And then this one reflecting about the y-axis would be -7 x. Wait, oops. Am I getting that right?
That is
And
correct. Yeah.
and then if it were the x-axis, then it would be basically right here.
And the other ones.
Gotcha. Okay. Oh, I got that wrong.
Oh,
The
y-axis. Sorry, I misread what it said. It is in the exponent.
Oh, so it would be -x basically. Like that.
There you go.
That would be a flip over the y-axis.
Yes.
And then if it
Not
was
the,
x-axis, then it would be
it'd be
that.
the other way.
Gotcha.
Yeah.
That makes
So
sense.
try this one, see if you can get it, and then we'll close out after this.
Perfect. And we've already been over this x -6. And the y-axis, so then that would be -3 and -x. Boom. Dude, you're
Good
amazing. I
job.
appreciate everything, man.
Yeah,
Seriously.
no, yeah, you're welcome. Glad to help. I'm gonna go ahead and stop the recording right here.